So the next question is linked list cycle 2, right? Linked list cycle 2. Over here, what do we do is, guys, in this question, not only we need to find out if there exists a cycle or not, but also return, if there exists a cycle, we need to return the address of the node from where the cycle is starting. Over here 4 is the location where from the cycle is starting. So obviously it is quite similar to the previous question. Also over here there are cases where there are no cycles. Over there we need to return -1. It is -1, right? If there is no cycle, we need to return -1. Okay, that part is clear. Now, obviously the brute force approach will be the same hash set approach, where I'll try to find that I'll make a hash set. Obviously it will be empty. Still I'll try to find out if this node exists. If not, I'll put this node over here. And then I'll move over here, I'll put 2, I'll put 3. I'll keep on putting all the nodes until 9. 4 will also be a part of it. After that, when I move ahead, there will be a 4. Before putting this 4, I will check if in our hash set this 4 was present. Obviously it was present, right? Because in the first iteration it was put in. So we say that, okay, now we get a node that is repeated, and that is also the first node to be repeated. Also if we move ahead, 5 would also have been repeated, 6 would also have been repeated, but 4 was the first element to be repeated, and that would be the starting point of my cycle. Pretty simple, right? The only problem is that we will be taking an order of n extra space, and we have to devise the strategy where we can do this without this extra space. So what I am telling is that this link, you can understand it is linked to the previous question. The name is also same, right? So what I am doing is, let me quickly show you what is happening. See over here, this was the code that I wrote, right? I'll just copy this thing over here. Instead of false over here, if a cycle is not present, I return -1, right? And if the slow pointer is equals to first, then a cycle is present. Then I should return what? I should return the address of the node from where the cycle is starting. So what I am saying is, as soon as my slow and first is meeting, as soon as they are pointing to the same node, what I will do is, listen carefully, I will move either one of the pointers to the head. So I will move my slow to head, for example, move my slow to head. Then what I do, I will run a loop until again I check for if slow is not equals to fast. Until my slow and fast is again becoming same, I am running this loop again, while loop, but this time what I am doing is, I am incrementing both my slow and fast to one place only instead of 2. So slow will go to slow dot next, and my fast will also go to fast dot next, and these two things will keep on incrementing until and again they are equal. Once they are equal, we will not go inside the loop, but I will come outside, and I can tell that whenever they meet again, that is the starting point of our cycle. So I can return either of them from here only. Will this work? Let me quickly check it first. So as soon as slow and first is pointing to the same node, I am moving my slow pointer to the head, and then I am checking until and unless. Okay, so I need to return null, I think. So in the question it is little bit deformed, so I need to return null, I think. Yes, it is running. So we will be, after moving one of the pointers to head, we will increment both the pointers by one step, and I am telling you that once they are equal, I can come out and return that equality portion, and that will be the starting portion of the linked list, and it is working. Now why this is working? Now this intuition is, see, there is a little bit of mathematics over here, simple mathematics, don't be worried about it, I will explain you. What I am saying is, initially your start and fast pointer was pointing to this portion over here, right? Then your start pointer kept iterating by one step. Ultimately your slow will move to this point over here, which is basically the starting point of the cycle. So I can tell you that when your slow was over here, your fast would have moved forward. So what I am saying, suppose I am telling you that this distance over here, this distance I am taking this as a, okay? So your slow pointer has moved for a distance. Now if your slow pointer has moved a distance, obviously your first pointer would have moved for 2a distance, because it is always traveling in double the speed. It is moving 2 steps, whereas slow pointer is moving 1 step. So for example, if my slow pointer is over here, it has jumped three times. For initially it was here, first jump, second jump, third jump, he jumped thrice. So my first pointer would have jumped 6 times. So once, twice, third, fourth, fifth and sixth. So my first pointer would be over here. So I can also say that if suppose I am considering that this A is of length 3, this 3 over here, this is the length of this A. Also I will tell you that this length over here, after this is also A, because this is also 3, because that is the extra distance that first has traveled. Now what I am saying is the rest of the difference, now the difference between this first and start, this I am considering as B, distance B, which is in this case it is also 3, right? Let me just quickly remove one particular node, right? Let me just quickly remove one node so that the difference of them are different. Okay, this is the thing. So the difference now is 2 distance difference. So this I am considering as B, which is 2. Now if I just take these things, obviously what is the length of the cycle? What is the length of cycle? The length of the cycle is nothing but A plus B, because there are how many nodes in the cycle? 1, 2, 3, 4 and 5. So the length of the cycle is A, which is 3, plus B, which is 2. This is the length of the cycle, right? And we also know that the difference between start and slow and fast is basically 2 units. And in the previous question only we discussed this, that once we reach this circular track over here, I can tell that the slow is moving ahead, moving away by one place, and the fast is trying to catch it up by moving 2 space. So overall fast is moving one place closer to slow at every iteration, right? So you can tell that if my start is over here inside the cycle and my fast is over here, remember the start is, slow. This slow is, I am taking that it is now currently at the starting point of the linked list, right? Now what I am saying is, in order for this slow and fast to be pointing to the same location, how many iteration steps do I need? Obviously B number of steps, because there are 2 spaces apart. On the next iteration my slow will be over here and my fast will be over here, guys, and they will be one place apart. So every iteration one place is removed or decremented. This difference is getting decremented by 1 in every iteration. So in 2 iterations I will be catching it up. So I can tell after B iteration both start and end will point to the same location, because that is the difference between them. So what I can say, that my start is, this is very important, start is standing at the starting point. After it moves B places, it will be similar to fast. So from the starting point of my cycle, my slow will move 2 places in order to meet fast. We will say that from the starting point it will move B steps. Then how much more space will be left? The total length is A plus B, right? The total length is A plus B, and you move B steps, rest A step is left, right? A steps are left to again move to the starting place, right? Basically slow and fast will be over here. After that slow will move over here, fast will move over here. After that slow will move over here, fast will move over here. Then slow will move over here. Then fast will move over here, right? Then slow moves over here, fast comes over here. Then slow comes over here and fast also comes over here. So they are meeting at this position over here. So this position is basically 2 steps, more 3 steps are remaining. So it took B steps, more A step is remaining. And also we took that this step, A number of jumps will make you move to the starting. So at the point where they met, from here only the fast was traveling 1 space ahead. So it need to travel 3 steps, jump 3 times in order to reach the starting point. And when they were meeting, I moved my slow to this starting position, after which it had to move this 3 times only to reach this starting point. And at starting point only both of them will meet. That is why when they were same, I moved my slow to head. After that, until both of them became equal, I moved them 1 step each. And when they become equal, I know that that is the starting point of the cycle and I returned that. As simple as that, guys. I hope the mathematics part was simple and easy to understand. Think over it. It is easy, we'll get it. I hope these things are clear now, guys. Thank you for your time.